Welcome back. This is going to be a short and unplanned episode to address something that I only noticed when I was editing the video of the previous episode. It's these chips, the 74244s. If you look at pins 4 and 7, they have a little slant. That's normal. It's part of the packaging process that TI used back in the 70s. But those slants on those pins tend to accumulate dust and humidity. So I need to look more carefully if that's leading to corrosion. Some of the other pins also have this dark coating on them. That's a chemical reaction that happens over time. In my experience, that doesn't lead to loss of material. It doesn't eat into the metal. So those are fine. I don't really need to do anything about those. That's my experience. I don't know exactly what that reaction is, but dangerous corrosion that eats into the metal looks dark orange. That's the color of the oxide from the tin pins that you get. To make sure, I just pulled out the microscope to look at those slanted pins on the 74244s. There are 4 of those chips on the board, and there you see it. That's pin 7. There is that slant on the right side, and I see some cracks on both sides up in that part of the package, just around that pin. And that's what can lead to corrosion. If grime and dust accumulating there, it absorbs humidity and can lead to corrosion. I don't see much oxide, almost nothing, but I also cannot see inside those cracks very well with the chips on the board. So yeah, at this point I was doubting, should I pull these 4 chips or should I leave them there? I didn't know at that point how hard it was to pull a chip from this board. It turns out to be harder than I had expected. Um, but to pull at least one to have a better look would be the best thing to do. You see, that's pin 4, and you see the 2 cracks again, with a sort of a hole that was formed by one of the cracks on the left side, and I can't quite see on the back of it. Maybe there is corrosion on the back of that pin, and I cannot see with the pin soldered onto the board. So I decided to pull one of those chips out, one of these 74244s, one of the 4, and have a better look. It's that one that I just pointed that I'm going to pull out. I follow my normal process, except for one thing that I regret not having done. I put good quality flux paste on all the pins first, and I reflow the solder on all the pins. But you will notice that I hardly use new solder now. I didn't flood those pins with new solder. I just reflow them with new flux. Normally that's more than sufficient, but I will come to regret this one for reasons that you will see soon. After using the desoldering gun with this vacuum pumping action, I also do a pass or several passes with the desoldering wick, which is very important. Much better to do it this way than to use a heat gun on the chip. I use desoldering wick on both sides, so the top side as well, until the holes are clearly empty of solder, which I will not succeed in doing this time. Um, because I didn't use more solder. And the reason why I had to use more solder will become clear later in this video. But I went through the entire process and the chip wouldn't come out. So the only thing to do was to resolder everything. Sorry for the magnifier being on the way. I really wanted to see what I was doing now. I used a higher amount of solder than usual to make sure that there would be thermal conductivity across the entire hole during the desoldering process, which is what I'm doing now again. But I also didn't want to use too much solder. Anyway, this now will work. Again, desoldering wick on both sides, and finally the chip will come out with no damage to the pads and traces. There will be a little bit of delamination on the board, which is when the layers on the board sort of don't adhere to one another very well anymore, and the board becomes a sort of opaque greenish instead of the dark green that it normally has. I'll show it later on, but other than a little bit of delamination, which is not really a problem, the chip finally came out fully without any damage to the pads and traces. But at this point I didn't know that yet, so I needed to give it a good clean with a lint-free cleaning pad, and I'll put a microscope there again, because I also was curious why was it so difficult to desolder this chip, one of the most difficult I have ever had. Um, but to see that, I need to give it a good clean first. And then I pull out the microscope. I did it from both sides, cleaning and imaging the thing from both sides. And this is not only to check that the pads are indeed intact, but to study something that I wanted to find out. And indeed, what I suspected was the case. The holes are not plated through. You see those little sort of linguet that you see folded to the sides. That's a little piece of metal that they put through the hole in lieu instead of plating through the hole. The holes are not fully through plated, and that's why heat conductivity was a problem during the desoldering process. It was not conducting heat across the entire hole because it's not metal plated. Okay, I forgive Sharp for this. It's 1978 after all. But it's good to have it in mind. Now, that's a little, I corrected one of the traces that had been cut by the former owner. I had put a bridge in there. That's gone in the desoldering process. You can also see the delamination. The green around the pads becomes a little bit lighter, more opaque. That's the delamination. When it's small like this, not a problem, but it can become a problem if it delaminates too much. So with the chip now extracted and clean, I look again under the microscope, both sides. I take a peek inside those holes and those cracks, and there is no dirt accumulating there. I also looked at the back of the pin, which I'm not showing here, but it wasn't a problem. This is the other side of the chip. These are pins 14 and 17 that have this slant. But there was no issue there. It was not corroded on the inside either. The holes were not filled with dust that accumulates water. So I didn't really need to pull this chip. Or did I? Or did I? Because once the chip was out, there it is, I thought, you know what? It's out now. It's clean. I might as well give it a quick test. I have the equipment to test these things. I just put it in there and give it a test, and I was fully expecting it would work and I would just put it back on the socket that I installed. But let's see what's going to happen. This is not a reenactment, this is the real thing. I was fully expecting it to be okay. First I do an auto find, and it doesn't find the 74244, it thinks it's a 74541. So that's the first suspicious thing. Normally, this thing knows exactly what chip you've inserted. But I go by hand and I select 74244 because that's what it is. And when I put the test vector in there, one of the pins consistently fails. You see in the third position from the left, it should be a low and it's always a high. Consistently. Everything else is fine, but that pin fails consistently. One of the buffers inside this EXA buffer chip is not working okay, which doesn't bode well for this board. And the first chip I test, it's already not working. I was thinking, oh, am I testing this right? Is this operator error? Am I programming this thing wrongly? So I had a brand new chip, 74244, also LS, right there. So I thought I'm gonna test this one as well. This one was manufactured last year, brand new. I just took it out of a sealed bag. Gotta be working. Let's see, and it does work. So it's not operating error. That chip was bad. In Dutch we say that it's geluk bij ongeluk. It's luck by accident. I pulled a chip that I didn't really need to pull, and it turns out that it was actually bad, but not for the reasons I pulled it. So I put the brand new chip in there instead of the defective one. And then if you remember, a little bridge that I had placed fell off when I desoldered the chip, so I had to redo that. And I decided to do it on the other side of the board. It was safer that it is. It looks screwed up a little bit around the soldering point because this board has flux varnish layer on it, which gets disturbed when I solder it. At the very end, I will put a brand new layer of flux varnish on the back of the board as well to look good. Another thing I had forgotten last time was to recap the two tantalum capacitors, which I replaced now. Tantalum capacitors are also electrolytic, and they do tend to fail as shorts. But they are in the power line, so the shorts would just blow the fuses in the power supply, no big deal. But, I have the board out, I changed them as well. And finally, it is done. Now, next time, we are going to look at the power supply of this thing. And we will be facing the question, do I replace this power supply with a brand new modern one inside the same case so it's invisible? Or do I go through the trouble of fully restoring this board? We will see it next time. Till then, take care. See you soon.